So the first thing with the nameplate, and I think a lot of you have seen the nameplate. I've told a lot it looks like a race car with all the different logos on there. Now for a manufacturer that has to ship products worldwide, we have to put all that stuff on there. So it can get through all the different countries, and it's got all their approvals on it, and it's a time-consuming process. But this thing can ship anywhere in the world. What I'm really going to focus on is what's here, is some of the ratings. Now I'm going to show you a few different ones, but we'll start with this one. So this one is 200 to 240. Now that's the rating. Can it operate wider than that? The answer is yes. And I didn't put it on here, but we'll test a product to -10 plus 6%. So it'll be -10 off of the 200, so that's 180. Plus 6 off of the 240, which comes out to 254.4, I think. If someone wants to check the math, you can. The next thing on here, you'll see this says 8 amps, but it has an X2. So what does that mean? That means that this thing has 2 power supplies, and each power supply is capable of 8 amps. So it'd be 1 plus 1 or n plus n redundant. Next thing on here is the 1.6 kVA. Now for the most part, on most labels, that's power equals V times I. So if I have a rating label that says 200 to 240, 8 amps, over here I did the math for you. V times I, it's 200 volts times 8 amps will give you the 1.6 kVA. Now again, what we're using is the low line voltage. The low line rating voltage is how we come up with that value right there. You'll see 50/60 hertz, it's just the normal frequency. Around the frequency, the range is plus and minus 3 hertz. So if you're 60 hertz in the US, you know, it's 57, 63 hertz. And the last thing, if you ever want to know, for example, if you're operating at 208, what the rating of that product would be, it's pretty simple. It's rearranging this equation. Take the power, divide by the voltage, and you get the amperage. So in this case, it's 1.6 kVA or 1600 VA divided by 208 gives you 7.7 amps. So here's another nameplate rating. This one's a little more complicated. It's still got the same old, you know, all this gorp on there that, again, so we can ship the thing worldwide. Now in this case, there's actually 2 power supplies that are supported. The 900 watt, this little tilde, looks like a sine wave, so it's AC. Then you have this solid line with dash line, and that means DC. And in this case, the voltage range is 192 to 400, which if you're familiar with higher voltage DC or using the high voltage DC in your data center, which will be 380, that's what this power supply can do. And it's important to note with these power supplies that it'll say 900 watt, 1400 watt. That is the DC output wattage. It's not the AC input. In order to get the AC input, you need to know the efficiency, where efficiency equals power out divided by power in. Now what you can assume, which I hate that word anyway, but assume that efficiency is 90%. Now for 80 plus type power supplies, it could actually be higher than that. But if you went with something like that, if you really want to know what the AC wattage would be, you can just go ahead and take that and divide by 0.9. Also, now this power supply has 2 ranges, the 100 to 127, 200 to 240. 10/5 amps, again, this X2 is there. And if you do the math, which I did down here, you have 100 volts times 10 amps or 200 volts times 5 amps. It equals to 1 kVA. Now, when I went through this label with one of my safety engineers, the first thing I looked at, I thought he did the label wrong, because if I take the 192 multiplied by 8 amps, it comes out to greater than 1 kVA. And I couldn't figure out. Like I said, I thought that was a mistake, and I sat down and went through it with them. So actually, The steady state load is 5.2 amps. One of the things with AC power supplies, I think hopefully everyone's familiar with inrush current. You plug something in and you're going to get a spike of current to charge the capacitors, the I equals C dV dt, if you've heard that equation before. Well, AC, because it's cyclic, it depends where you plug it in. And where you plug it in, you're going to get a high surge of current. It's going to go ahead and come down pretty quick. With DC, though, when you plug something in, the capacitors will charge, but they'll charge more at a constant rate for a longer period of time. You don't have that cyclic effect where you're going to get a high current for a short period of time. Because of that, we have to reflect that on the label. So that's why it says 8 amps, because we have to make sure that we publish that because of the inrush current for this box. So last thing with nameplate on server, storage, networking type devices. A lot of times, and I know this, I've been in a lot of data centers, these things are stacked up in racks. You can't see the nameplate, and if you really want to see it, what are you going to do? You're going to pull the product, slide it on its rails to see it. It's always just not in a good spot. A lot of times they sit on top. So if they sit on top and you put a piece of equipment there, right, you're not going to see it. Or if it's the side of the rack, you're not going to see it there either, especially if the rack has side covers on it. But there's a few things that you can do if you don't see the nameplate. The first thing is just really look at the power supply. This thing has a C14 inlet. A C14 inlet is the max rating is 10 amps. So you know that the max this will be is 10. Now, but for the most part, it's going to be somewhere in that range. I showed you one that was 10. I showed you one that was 5. But the max will be 10. The second thing is right here. A lot of our power supply manufacturers are going to actually putting the rating on the fan itself. So this, for this 900 watt power supply, everything I showed you, which I know you can't see probably in the back, but all that information is there. Already mentioned the nameplate includes all the stuff we can ship worldwide. The last point I want to make, and I do get people ask a lot about this, is why your nameplate value is so high. And it's a common question. Well, the first answer is we're getting better at making sure they're not so high, right? We want to reflect reality, but at the same point, we want enough buffer that if a product is upgraded in the field, that it could still support the load. The last thing we want, let's say we rated something that was 3 amps, and with the next generation of processors, it's 4 or 5 amps. Well, if that's the case, there's one of two things we need to do. We either need to ship you a new chassis and swap everything out, or we have to bring someone from Product Safety Agency out to the field and field market. Both things are expensive, both things are time consuming. So best thing to do is to overrate it a little bit, but don't use it for anything else but the premise wiring, for electrical code type stuff, for overcurrent protection. Don't use it for loading of a UPS. Don't use it for determining ampacity on power panels. Don't use it for your mechanical type air conditioning loading. These values should strictly be thought of as electrical code type stuff.